Hey, welcome back for another virtual IoT webinar. We are today with Julien Vermeer from Sierra Wireless, and more specifically from the Eclipse Leshan and Eclipse OMA projects, because since today's topic is going to be sorry about that. Yeah, today's topic is going to be device management, and the Lightweight M2M standard is something that's been around for a couple of years now, and at Eclipse there's several open source implementations that allow to do device management. So I think Julien has prepared some slides as well as a few demos of what it means to do device management on top of Lightweight M2M. A quick general announcement before leaving the mic to Julien. Please let us know if you have questions, two ways to do that. If you're on Twitter, feel free to tweet and use the virtual IoT hashtag to send us our and to share your questions. We'll send them to Julien. Or another way would be to use the YouTube comment section, and you can certainly interact there, and we'll collect your questions there as well. So without further ado, Julien, welcome, and it's up to you.
Thank you. So hello, everybody. I'm going to switch to my presentation. So I'm going to introduce myself and the presentation. Yes, let's.
Okay. You're all good.
It's okay. Okay. So I'm going to talk about connecting objects or IoT with Eclipse Leshan and the Lightweight M2M protocol. So yes, so I'm going to introduce what is Lightweight M2M and Coop. Coop is is a protocol under Lightweight M2M. More detail on that. Then I make a little demo so you understand more what is exactly Lightweight M2M and how you can use it. Then I will introduce you the Eclipse Leshan project, and I will show some code how to use Leshan for creating clients or server. And I will finish by provide you some information about how we use the Eclipse Leshan project on our own commercial product, which is the Advantage Cloud Service. So yes, so who am I? I'm Julien Vermeer. So I'm principal engineer at Sierra Wireless. My main job is to connect device to cloud. So basically, I work on the Advantage Cloud Service, and specifically on the server and everything related to device to cloud communication, and also device to cloud security and key distribution, etc. I'm involved in different Eclipse IoT projects like Leshan, Californium, Wakama, since a few years now. If you want to contact me, my email address and my Twitter account. Of course, if you have questions, please use virtual IoT hashtag. So yes, so a little introduction. So few years ago, and at Sierra Wireless, we are doing that for decades now. You have what we call machine-to-machine, a bunch of machines you want to connect to a server using wireless communication. Most of the time, you use cellular connections. And you have the same kind of machine, and you connect this fleet of machine to a server for managing it or building an application like gathering telemetry values. But since the last few years, we have now new technologies like the low power network, or the Bluetooth, Thread, low power, wide area protocols, IPv6 for everything, going from large network to very small low power network, and all these new technology permit to connect new objects, which are very small objects, very constrained, with very lossy and constrained networks and small CPU and small memory. So there is a new concept of trying to connect more and more stuff, like very basic object, and those objects are able to communicate using maybe a very low power technology like Bluetooth, and the object is going to be very limited. It's not going to host a very big application. So you want to keep your device as stupid as possible, just exposing the feature and put the application and all the big processing in the cloud on or in the gateway or on the mobile application. So for that, there is a protocol called Coop, which was created by IETF, which is now a standard. So the idea is to create an application protocol for constrained devices and constrained networks. So exactly what I presented before. So very small devices with few kilobyte of flash, few kilobyte of RAM, and the target is more $1. Of course, probably not running any big operating system like Linux, maybe something more a real-time OS or non-bare metal, and compatible with low power networks, which are very constrained because the max size of a message is maybe 100 bytes, and with a high packet loss rate. So what is Coop? So Coop is ready to create an HTTP. You have all the same concept as HTTP, like verbs, get, post, put, delete, URL, and media type, with some specific feature for IoT. But it's very compact. It's created for being very simple to use on constrained devices. So it's a binary protocol. For example, here you have the structure of a Coop message. So you have a 4-byte headers, you have a token for correlating response and answer, and you have the options. Options are a bit like on HTTP, the header, but encoded binary. Like if you want to issue get on a device and you want to please answer me with this content type like JSON or CBOR or whatever, you can do that putting an option like you do it with HTTP, but you use a binary value for expressing the content format in place of writing application/JSON on a ASCII string. You provide a binary code, and then you have a payload, so you can answer or get with a payload or post a value with a payload. So it's really HTTP, but for constrained device. So you have this HTTP for constrained device, and on top of that, some other people say, oh, it's nice, but we would like to have some kind of standard to be able to manage our devices. So what I mean by managing is operating your fleet, monitoring your fleet, upgrading your fleet. So for example, securing it by, for example, distributing key, distributing certificate, also configuring the device, but configuring the basic feature of the device for connecting to internet, monitoring, I don't know, the signal of your device. If you use a Wi-Fi or a cellular device, you want to be able to monitor, does my device is having a good signal level, or does I need to send someone to fix this issue? And you want also to be able to upgrade the firmware and maybe the application. So if you have some application framework, you want to be able to install an application, remove an application, start the application, remove, for example, and install the application, and of course everything around monitoring, which is, for example, to know how much data your device is using, for example, for preventing an overconsumption or detecting a security issue with your device. And since your hardware is probably going to be change during time, or you don't know if you are going to keep the same hardware all the time. You want to be able to do that with a standard for having, for example, a consistent way for uploading a new firmware to your device. You want to be to have a standard for sending these files and gathering the firmware upgrade result. So that's why the Open Mobile Alliance created this standard called Lightweight M2M. So basically, it's for a device management and application API on top of Coop. So what it's describing is mainly describing resources for doing all the device management feature I talked previously, like security provisioning, monitoring, gathering, for example, location. So if you have a GPS module on your system, you have a standard way to get the GPS latitude and longitude and altitude and maybe the velocity and precision. You have an object for doing the firmware upgrade, for managing software, and also for reporting problems. So you have all those different objects defined in Lightweight M2M. For example, you have the object device. So you have the object device. An object device for a device is useful for presenting some basic information configuration, which are common to every device in Lightweight M2M, like the manufacturer, the model number, a serial number, the current firmware version, also an actions, which is called execute in Lightweight M2M for rebooting the device. So you have the same URL, the same Coop URL, like 304, for sending an order to a device for rebooting. So whatever your fleet is, for example, TV, fridge, a car, if they support Lightweight M2M, you are going to use the same URL for triggering a reboot or reading the firmware version. And also a lot of other device management features like managing power and reading the current time of the device and setting the current time of the device. So you are able to read, to write values. If they are writable, for example, you are not going to write the model number, it's read-only. And also you have a feature called observe. So this feature is not something you can map to HTTP. Is, for example, I have a battery level, so I want to observe the battery level. I issue an observe on that. It's a get, but with a special option. So you are going to receive an answer from the device with the first value of the battery level, so like 100. And every time the battery level is changing, the device is going to push to the server the value of the new battery level. So it's going to stream the value back to the server. It's like issuing a get and gathering a stream of response. So yes, so all the objects Lightweight M2M have this structure. So you have an object ID. For example, the object device I've shown you is the object tree. And for example, the location, which is GPS location, basically, got the number 6. And if you issue get on object 6, you get the whole information about GPS location in a binary format, like latitude, longitude, speed, etc. But if you just issue get on 601, you just get one resource, so only one value, like the longitude. So it's a bit like a REST API, but using Coop and using a binary format. You can also extend it, so you can define your own object, and also if you think it's valuable to have it standardized, you can register at the Open Mobile Alliance. They got a registry for standard object. So for example, you have the IPSO. So this is the IP for Smart Object Alliance, which is another standard body, which created a bunch of objects for describing common sensor, like digital input, digital output, accelerometer, temperature, humidity sensor, etc. So if you have a device which is using this standard, this IPSO standard for providing a temperature, it's anybody without knowing what exactly your device is will understand that is a temperature and how it should behave. And you have also more extended IPSO object for more advanced sensor like color, gyrometer, a buzzer, loudness. You have quite a lot of objects for that. So how does the device to server workflow work? So the device is going to start to register with the server, so sending a post on /rd, so for doing what we call a registration. So basically the device say to the server, hello, my name is, gives is identifier, and this is a list of object I'm supporting. So for example, I'm supporting object 3, object 6, object 9. So it does mean I'm supporting the device object, the location object, maybe the object 5, the firmware object, and also I'm able to do software management with object 9. So once the server receives this request, he say, okay, your registration is created, and give you a key, a token for updating the registration later. And once the device is registered, the server is able to start sending requests. For example, I want to read the object 30 and get the device object. So the device answer with a binary encoded device object, and then the device can go to sleep, or the server can continue to send message, or and at some point, after some time, the device will need to extend the registration of the device for saying, hey, I'm still here. So depending of what the device and the server are negotiating, is going to post on the token the server gave during the registration to extend the device registration. And if the device is not sending, after some time, not sending the device registration update, the server will say, okay, this device is offline or is disconnected or have a problem. So let's do a demo so it's get more concrete. So yes, so I have what we call the Leshan demo server. So I will explain you later what exactly is Leshan, but so I have a device here. Okay, so I have a device. I'm going to launch a Lightweight M2M client on that. Okay, so it's connecting. So so I see the device with the name Julian, with the registration ID. So this is a token for the device to do the update. And we see the last registration date and when the device did the last update. And we have some more details here. So the device give what we call the lifetime. The lifetime is basically the device say, I'm going to extend my registration, doing a registration update every 30 seconds. So after 30 seconds, if the device don't do the registration update, the server will think the device is dead. So if I look at my device, I can read, for example, the object device. So I can see the manufacturer. So it's a Sierra Wireless modem with a model number WP8548. This is the serial number, the version of the firmware, and we get some other information. So what we can see here is that the current time is not updated. And for example, my device got an accelerometer, so I can read the value of the accelerometer. So I get the XYZ value from the accelerometer. So we see -1 that the direction of the device is flat on my table. And if I do an observe on that, so we see the different values that are streamed, and I can change, turn around my device, and I see the value are changing. So I'm able to read this accelerator value, and I stop the observation. And also we have some other objects. So this one is server. So it's basically everything about how the device need to communicate with the server. So you are, for example, you are able to change the lifetime of the registration. So if I say 300 seconds, the device is going to send an update every 300 seconds. So if I change it again, the device is going to register more often. You have also some capabilities for putting a device offline for a few minutes. Yes. And if you look at details of the communication, so it's not very easy to show here. So if I do a read on, I don't know, on manufacturer, okay. So what we see is we send a get on 300 with a given content type, and we get an answer for the device, which is binary encoded. This is the co-op message. Okay, so so security. So the security is based on DTLS, so which is basically SSL for datagram with standard DTLS feature like AES encryption and ECC for doing for managing certificate and stuff like that. So you can use TLS with Preshot Key, which is basically using a pre-configured password between you, the client, and the server, or use ECDSA, so basically for using a certificate like HTTPS certificates. So I'm going to pass this section. So what is Eclipse Leshan? So Leshan is a Java library for implementing server and clients. So it's really a Java library. It's not a server or a client ready to use. It's a Java library for you building your client or your server for example, implementing your behavior, to read how to read your model number, or to do your firmware upgrade. All of that, you need to implement that. It's a very simple Java library without any framework, with only few dependencies. So it's based on Eclipse Californium, which is co-op implementation. And you have also a web UI. So what I show you during the demo, it's a web UI for discovering and testing your device and discovering the protocol. It's built using Maven, and yet it's based on Californium and Scandium. You have a public sandbox for testing, so it's deployed on every commit, but it's always the last version of Leshan Master. It's supporting IPv6 and IPv4, and so you can use that for testing your device or learning the protocol. A lot of people are using it for understanding what is Lightweight M2M. So Leshan is split in a lot of modules because we want to provide a server, a client, and some modularity. So for example, you have the core with the common Lightweight M2M elements. You have the server core with the Lightweight M2M logic. You have the Lightweight M2M CF module, which is the implementation of the Lightweight M2M using the Californium co-op implementation. But for example, you can remove this part and put your own co-op implementation, or do crazy stuff like implementing Lightweight M2M over HTTP or MQTT. And also for the client, you have the same modules, and you have a Leshan-all for everything in one jar if you don't care and you don't want to know if you need to use Lightweight M2M. If you need to use Leshan server CF or Leshan server core, etc. Just get everything, and you have some demo of a client, a server, bootstrap server, and some integration tests which are running the client and the server together. So if I show you a bit of code, so this is a client. So this is a Leshan client. So you need to provide your identity. So here my device is going to get its identity by using the EMEI of the modem. So, but you can put whatever you want here. Provide your own identity, and here you are building the object you are going to support. So for example, here it's a helper for creating a security object so this is for managing the security keys, a server object for managing the server connectivity, the device for providing the device details, and here's the accelerometer. So for example, if I show you my device object, so my device object is a very simple object. It's going to provide so what you need to do is to implement the read method. So for every resource ID, for example, for the manufacturer, you need to send the manufacturer, you need to send your model number, etc., etc. So here I provided my hard-coded values, and some I'm reading on my modems, but basically it's not so. It's just that you provide implementation for the read method and implementation for the write method. For write method, for example, if we receive the time zone or the UTF offset, we are just going to do some behavior and answer, okay, success, I managed to write the UTC offset or the time zone. Same for execute. So execute is more commands. So for example, if you receive reboot commands, so what you can do is rebooting, or in my stupid example, just print reboot. But here you can do a system execute of the reboot command. So this is the client, and you can add your own object, like here the accelerometer. So how does the accelerometer work? So it's implementing the read and write, like where is the write? No, there is no write, it's just read. So when you do read, it's sending the last x, y, z value we are storing in the object. And we have a thread here, a timer running every half a second to just read the value on the accelerometer data. So it's reading the value using I2C on my device. And once we get that value, we do a notification. So in case someone is observing this resource, Leshan client will automatically push the notification to the server. And yes, that's all. It's very simple to write a client. And if you want to write a server, it's a bit the same. So here is example of a server which is very basic. So you start to create a Leshan server. So you have a builder for configuring everything. So we just use the default config. So we just call build, but if you want, you can customize. You can customize, for example, your binding address or your security registry for the security key you want to use with your device. And here, a listener for which is called every time a new device is registering. So every time a new device is registering, what we do, we look, does this device is supporting the accelerometer object? And if it does support it, we send a request to ask to observe the accelerometer. So every time a device registers with this server, we will observe the accelerometer value. And then we created another listener for observing registration, observation notification. So every time a new value is coming, we get this method is called, and we are able to get the different values for the accelerometer, and we are able. Or here I'm just printing it, but for example, you can store it in your database for storing your telemetry values. So this is Leshan. So it's a Java library. It's very, as you can see, it's plain Java, and you have nothing to do more than implementing those listener and running running the code. So this is the Leshan client, is a client in Java, so it's not really good for constrained devices. So you can run it on Linux target using Oracle or Azure embedded Java runtime. But if you want something more embedded, you can use Wakama. It's a C implementation of Lightweight M2M. It's also an Eclipse project. So you can run it on Linux, but also on very small microcontroller like ARM Cortex M processor, ESP. It's very simple. You can use it with on any target, but without any operating system. What you need to provide is a callback for writing and reading UDP packets, and also time of the day value for computing things like retransmission. But it's very easy to port to any microcontroller, like on Mbed or FreeRTOS or RiotOS. It's very easy. It's nothing specific to Linux or big machine. And also you have the Eclipse Tiny DTLS, which is a compact implementation of DTLS security layer to be used on top of Coop. So those two projects make it very simple to run a Lightweight M2M client on a constrained device. So now I'm going to explain you what we are doing at Sierra Wireless for with Leshan. So what Sierra Wireless is doing is a manufacturer for modules, cellular modems, which you can put on your PCB board, inside your object to connect it to the cellular network, like 2G, 3G, LTE connectivity, or new low power LTE standard like LTE NB IoT or LTE Cat-M, but also router gateways for creating extension for you have an IT network, you want to extend it using cellular connectivity, you can use this kind of router. And we provide a service platform for managing the devices, for building an IoT application on top of that, and also for managing your connectivity. We are also providing connectivity for by providing SIM cards, and we have a service platform for managing all those stuff. So, which is called AirVantage. So what is AirVantage? So we have three main features on AirVantage. So device management, managing devices, sending command, doing upgrades, doing configuration of your device. For example, if you have a fleet of 1 million devices, it's quite difficult to send the order to every device, to wait the device to be connected, to send the order to download the firmware, and to gather back the status, and also to serve all the massive data for doing a firmware upgrade. So AirVantage is providing that, and tracking all the results and providing a report on how your fleet is upgraded. what we call application enablement is collecting, gathering data, and visualizing the data in dashboard. A root engine, for example, for triggering alerts on application data, and integration with different backends, like I don't know, Google PubSub or Azure Service Bus or IMQP for pushing to your own data structure. And connectivity management. So connectivity management is managing your SIM card. If you have a SIM card, we use your system for monitoring the usage, providing alerts for preventing bill shocks, and also activating, deactivating SIM remotely. So I'm going to do a little demo of N4. Yes, so you, of course, you can plug all the CROLS hardware is ready to use with Advantage, but you are able also to connect third-party device like any wired device or any connectivity to Advantage for pushing your data, or to being able to manage it remotely, like doing firmware upgrade. But for that, we use a standard protocol, so like MQTT, mainly for telemetry values, Lightweight M2M more for device management or application, and HTTP for device which don't care and can use a simple HTTP REST commands. So I can show you a little what is Advantage is.
Julien, maybe a quick question while you
Yes.
switch to the demo. I think the question is actually twofold. It's regarding NB-IoT, narrowband IoT. So does Lightweight M2M support narrowband IoT? And I guess to some extent, you can also answer from a CROLS and Advantage perspective. Is narrowband IoT supported there as well?
So so for basically Lightweight M2M is using Coop, and Coop it's built for running on very constrained network. So it's possible to use Coop on 6LoWPAN and very constrained network. So it's working also on NB-IoT. You need to use IP connectivity on top of NB-IoT to push your UDP packets in NB-IoT packets and send it to the cloud. Lightweight M2M is, as the name said, lightweight, so it's really targeting this kind of devices. So you are able to use it on a big box with a 4G connectivity, but also on very small device, and specifically on NB-IoT. It's probably the only device management protocol to be able to run on this kind of technology. So I'm going to connect to Advantage. To change company. This is a demo company. So you have a dashboard with the status of your fleet. For example, does your device are active or in inventory, also suspended, or you have the state in maintenance for managing your life cycle of your device. The communication status to know if your fleet is communicating, or some are broken or some are never communicated. And yes, you can see the different application that deployed on your. I don't want to do that on your fleet, and the location of your devices. For example, I can see where are my devices the last time they communicated. You can see the recent activity, the different alerts. So here is it's a container management system. So when the accelerometer is crossing some threshold, you get an alert for saying, hey, this container got some problem. And you can manage the airtime usage. So we can see month per month the current usage of the fleet. So if I show you more details on the system, so let's find a system communicating using Lightweight M2M. So we are supporting, as I said, a lot of different protocol, like some proprietary protocol, but also MQTT and lightweight M2M and HTTP. So if I look at some real device, so yes, this one, see this one, connecting. This one is not connecting. No, this one is for. Okay, so I can see the daily usage of the data for my device, the last operation I did on that. And I can see the last communication of my device. So for example, I can see that he's communicating with lightweight M2M, doing some registration, sending some values. We see when the device started to activate the SIM for doing a data session, and when it stopped the data session and how much data I used. So you can see it's quite lightweight. I started the communication and then sends a few data, and only 2K byte was used. We can see the details of the communication. Yes, so this is all the data the device sent using lightweight M2M, of course. And if I see my device, so I'm able to do some different device management operation, like configuring the communication rate, doing a firmware upgrade. So here I can configure the communication. Oh, and I can do a firmware upgrade. So I can select a new firmware and do an upgrade of my device. Or if I have a fleet of devices, I can select my devices, and do a bulk operation like rebooting, synchronizing, sending, exporting the data. A lot of device management feature. I'm out of time, yes. So you can also create some custom dashboard for showing your data, your applicative data. So this is how we use lightweight M2M for basically connecting devices to our cloud and providing device management and application features. So thank you. I think we can go to question now.
Yep. So as a reminder, so thanks already for the very interesting presentation. As a reminder to everyone watching, one way to ask a question is to comment on YouTube, or you can also send us questions on Twitter using the virtual IoT hashtag. So I actually have a question myself. I think you mentioned a couple of times that by default, Coop and therefore lightweight M2M are using UDP. However, I think it's kind of hard to scale UDP, and maybe also for going through firewalls, and when you have cellular connectivity, UDP might sometimes be a challenge. Is TCP supported as well?
So there is a draft for supporting Coop over TCP. It's going probably to be included in the next release of the lightweight M2M standard. So today, lightweight M2M is going to be released as 1.0, and the next version is going to be 1.1, and it's probably going to support Coop over TCP, because yes, as you said, a lot of people request that. Because if you want to be always connected, if you are not so constrained, using TCP can have some good feature over UDP. Like a lot of cloud environments are not really supporting UDP and use the TCP, and it's under integration on California mainland. So we are probably going to have a support for TCP probably before lightweight M2M 1.1 spec is done. But yeah, it's going to happen, and also some people are interested to port Lightweight M2M to some different technology other than Coop, like using MQTT, for example, because for MQTT, you don't have a standard for doing device management. You have publish, subscribe pattern. And some people say it would be nice to have some kind of model for providing resources and providing a common way for doing a firmware upgrade, for doing a configuration management, etc.
Right. Speaking of models, actually, are there other initiatives than IPSO for providing standard description of stuff? Like, I think IPSO is very lightweight, I guess, in terms of describing what a temperature sensor is or what a luminosity sensor is. Are there plans to go further than that?
I think you have some objects in 1M2M, but I don't know if things if standard like OCF are providing their model on top of Lightweight M2M. I need to check, but yes, today the objects are quite basic and simple because the idea is to be able to run that on constrained devices and constrained networks.
Right, that makes sense. Just wondering if there are more questions at this point. Just waiting for you guys to maybe send a few more questions. I will very briefly share my screen so as to remind you all. I think we actually sent you guys an email recently about that. The Open IoT Challenge. It's actually the third edition of the challenge. We've been organizing this for a couple of years now. The way it works is that you have until November the 25th to let us know what you would like to build on top of open source software, what kind of IoT solutions, and we're particularly interested in kind of end-to-end IoT solutions more than just blinking an LED, I guess. And so if you have an interesting idea, just let us know. You can easily apply from the website. So it's on the iot.eclipse.org website, and it's right on the homepage. You really can't miss it. So you need to apply. You need to let us know what you're going to build. The reason why we want you to apply is that if we really like your proposal, you might actually get a development kit and help to get to buy the hardware you will need for building your solution. But the actual solution you will have until February next year to actually build it. And if you make it to the final to the podium and if you're one of the finalists, you essentially have a very nice prize pool to share with the others, and we provide you with cash, with a scholarship to attend Eclipse conferences, etc. So it's really a nice challenge. You can certainly look in Google for the entries from the previous years. People have built cool stuff with MQTT and Lightweight M2M, Coop, Cura, etc., etc. So yeah, you really should check that out. And in the meantime, let's see if we had any further questions. I think that's basically it. I don't see further questions. So maybe one last question from me, Julien. Well, you actually removed your slide, but I think if people want to learn more, they go to eclipse.org/Leshan or eclipse.org/Wakama for respectively Leshan and Wakama.
Yes, for Eclipse Leshan, you have a website on eclipse.org/Leshan. For Wakama, the best is to go directly on the GitHub. You have a README, which is quite good introduction of what is Wakama. You don't have a website for Wakama. And yes, and about the challenge, the IoT challenge. So don't hesitate if you have an idea, if you need the support of the community, don't hesitate to reach the project using the mailing list. And I think, yes, don't hesitate to communicate with the different projects for helping you.
Yeah, I think last year some people wanted to port Lightweight M2M to different devices. That's typically something that would been the scope of the challenge, right? You have this super tiny microcontroller, super low power, and you want to port it. I think actually Sierra has a bunch of like nice hardware that could be used. One last thing, do you? Well, I guess that's more to the people watching us. It's great at Eclipse to have a C implementation of Lightweight M2M as well as a Java implementation. If you guys are using Lightweight M2M or want to use Lightweight M2M in other programming languages, I think, for example, Node.js would be an interesting candidate. I would love to chat with you guys and to see what you're doing with Lightweight M2M. It would certainly be great to have other non-C and non-Java implementations of the standard. So you know where to find me. And with that, I think that's a wrap. The next virtual IoT is going to be in a couple of weeks. I'm not sure. I'm pretty sure we actually haven't announced it yet. So stay tuned. If you guys want to talk and present at virtual IoT, you also know where to find me or where to find us. So let us know. Feel free to review and to comment also on the meetup group to let us know what you thought and what you would like to see. We're always looking forward to get your feedback. Julien, thanks very much.
Thank you.
I think you will put your slides online, right? So if people want to browse them offline or want to send you questions by commenting on the recording on YouTube, they can certainly do that.
Okay, thank you.
Thanks very much. Bye-bye. Take care.
Bye.